A very warm welcome to the respected lecturer and to all the fellow viewers. Today, as for the operating system group assignment, me and my group have chosen topic 2, which will be scheduling algorithms. And without further ado, I'll present my part of the topic, and which will be primitive shortest job first. And thus, our question we have submitted in the report. And proceeding with my part of the presentation, this is the schedule for step 1. In this schedule, I've stated process, burst time, arrival time, and priority. And yeah, according to the discussion and study, our process is process 3, process 1, followed by process 4, process 2, process 5, process 6. And then the burst time for the each of the process will be 9, 6, 3, 5, 7, and 4. The arrival time, as it follows: 0, 2, 4, 6, 6, and 8. And priority will be 1, 5, 2, 3, 4, and 6. And thus, moving on with the schedule for primitive shortest job first, which will be primitive as JF. As for first process, you will be getting process 3, and that is because 3 has the highest burst time, which is 9. And thus, it ends at 2. Looking at the table, it ends at 2, and at 2, we get two processes, which will be process 3 and process 1. Process 3 and process 1 ends at 2. And thus, process 3 will be burst time number 7. Process 1, the burst time will be the burst time 6. And the reason why burst time for process 3 is 7, and that is because we have deducted the time, which is 2 millisecond, and 9 minus 2 is 7. All right, then moving on, we choose the process for this, and process for this schedule will be choosing the lowest burst time, which will be p process 1, thus followed by uh, the end time, which will be 4 stated here. And we will get three processes, which will be process 3, process 1, process 4. And likewise, the burst time stated here: burst time 7, burst time 4, burst time 3. And we have minused exactly with the difference, which will be 2, 4. The difference between them is 2, and we have minused 6 minus 4. Sorry, 6 minus 2 will be 4. So thus we'll be choosing the lowest burst time, which will be 4 again. And thus we will also look at the next process and the end time, which will be 6. And at the end time of 6, we'll be getting process 3, process 1, process 4, process 2, process 5. And for all of them, we have equally calculated and stated their numbers, which will be burst time 7, burst time 4, burst time 1, burst time 5, burst time 7. And we look at their end time, which is also known as arrival time. And this is what we have got. And for process, we have chosen the lowest burst time, which will be 4 again, process 4. And the end time is 8. And at 8, we get process 3, process 1, process 4, process 2, process 5, and process 6. And over here for process 4, uh, no, not process 4. After getting all of these processes, we state the burst time 7, burst time 4, burst time 1, burst time 5, burst time 7, burst time 4. And as you can see, we have stated all the arrival times. And right now, it's time for us to state the plus with the burst time of the current lowest process, I mean current lowest burst time, to get the next arrival time, which will be process 4, burst time 1 plus 8, will be getting 9, thus terminating process 4. We are left with process 3, process 1, process 2, process 5, process 6, and process 3 will be burst time 7, process 1 burst time will be 4, process 2 burst time will be 5, process 5 burst time will be 7, process 6 the burst time will be 4. Thus, following with the next stage, which will be the lowest burst time, which is 4, and will be adding it with arrival time 9 plus 4 13, and at 13 we get process 3, process 2, process 5, process 6. We terminate process 1, and process 3 will be burst time 7, process 2 burst time 5, process 5 burst time 7, process 6 burst time 4. And over here we get this 17, which is because process 6 is the lowest for process 6 burst time, and we stated process 6, and 13 plus 4 will be 17, and we are uh, left with process 3, process 2, process 5. Thus, we are terminating process 6, and the lowest process for this stage is process 2, which will be process burst time 5. Before this, since we get two numbers same burst time here, we'll be taking the number which has the lowest priority, and we'll be doing the same here. But first we'll choose the lowest burst time here, and we'll be terminating lowest burst time P2 will terminate process 2 here, and will plus 17 plus 5 22, process 3 burst time 7, process 5 burst time 7, both have the same burst time. We'll see the lowest priority, which will be um, process 3 and process 5, process 3, process 5. Process 3 has the lowest burst time, and we have chosen process 3 burst time 7, and thus we'll end up with 29, which is 22 plus 20, 27 is 29, and we are left with process 5. 29 plus 7 is 36. And moving on to our next stage, we will find waiting time for our primitive shortest job first schedule, which is primitive SJF. Waiting time process 1 equals to 2 minus 2 0, process 2 equals to 17 minus 6 equals to 11, process 3 0 0, 0 minus 0 is siphon, and process 4 equals to 4 minus 4 is also siphon, and process 5 equals to 29 minus 6 23, process 6 equals to 13 minus 8 equals to 5. And thus this is the waiting time for each process. And moving on with our next stage, we'll be calculating the average waiting time, which is also which will be additioning with addition everything, total everything, all the waiting time, and divide them with the number of processes, which we have 6 processes. We total the waiting time and then divide them with 6 processes, which will be 0 plus 11 plus 0 plus 0 plus 23 plus 5 divided by 6, and the answer will be 39 divided 6 equals to 6.5 milliseconds. That's it. Thank you very much. Have a great time.